Hey everyone, today we're going to be looking at an LXP-15 digital effects processor made by Lexicon. This is a very nice processor in its day. It's still very relevant today for various digital effects. Lexicon's really known for the reverb. This is by no means their highest end unit. They have various models that are really renowned in the audio recording industry and home musicians, things like this, for their very, very accurate and realistic sounding reverb. This particular model was also very well liked. It just wasn't at the same price point as the higher end models, but overall reviews of it were pretty well and still are pretty well to this day. There was a second model of this. This is, I guess, what you could call the Series 1. There was an LXP-15 Series 2 that came out later. This model was early to mid 90s. I think it was late 90s when the LXP-15 Series 2 came out. The only difference I can tell between the two was it was just a software update. So there's an EEPROM inside this unit that was actually replaceable. And you can still get that EEPROM today to upgrade the original unit to the Series 2, which provides, the software algorithms in the software, things like this, provide more realistic sounds and a little bit better quality, I believe. It might be something to look at in the future. So this video today is actually going to be kind of a teardown / repair of this unit. This was an eBay special. It was marked, the auction was listed as something wrong, fixed repair. The effects were, it was labeled as it had interesting effects that were distorted or something like this. It sounded interesting to me in terms of repair because the unit powered up, it seemed to function properly. The seller said that everything worked, it's just the audio output of it wasn't right. So based on that, it could be numerous things. It could be obviously something simple as a power supply problem. It could be more in the digital domain, which I was kind of thinking. Based on the description that he had described, it sounded more like it was kind of digital artifacty or something like this, which could lead to, anywhere in the digital chain between the analog digital converter, the digital analog converter, all the DSP processing and RAM in between that processes it. So it was cheap. It was only listed at $50. Shipping was reasonable too for $12. These things working go for $150 upwards, depending on condition. This one's actually pretty clean condition. I was happy with it. So it will be interesting to take a look inside. It'll be fun to see what makes this thing run, along with see if it's repairable, which I'm hoping it is. Overall quality of it, it's definitely heavy. It's not a light unit by any means. Big steel covers. Standard 1/4 inch input outputs on the back, 120 volt IEC in. It's got MIDI connectors, which is nice as well. Something I'll never use. Again, I just play around with music in my little tiny home studio. I'm by no means a serious musician or anything, so this will just be something for me to play with if I can get it working. But we'll take a look inside and power it up and just see how it sounds and see if we can actually debug what the problem is. Here in Michigan, it's actually pretty cold right now. This was sitting outside after it was delivered, so I had it sitting down in the basement here for about an hour. It feels like it's up to room temperature, so there shouldn't be any condensation on it, but I will go ahead and open it up first. I'm really kind of curious to see what's inside this guy. Alright, take a look inside. Oh, it's a big board in there. I wasn't expecting that. Linear power supply. Definitely old school, early 90s construction. So we'll take a little bit closer look at this here. Here's a look inside. A lot of digital logic going on. Analog power supply. I think I had mentioned that. One thing I noticed right away when I opened this was a smell. And it's a very distinctive smell that I knew right away what it was. The smell of basically leaky caps. And if you look back here, this cap on the power supply has definitely been leaking. You can see a little bit of corrosion on the board there. The acid's actually kind of staying this label sitting next to the power supply there. The caps themselves are nice. They're Nichicon units, 105 degree Celsius rated, so they're good caps. Just the age of this unit, maybe a proximity to that heatsink, just got too hot over time. I mean, this studio gear too, it could have been left on all the time. For all I know, this thing may have 20 years plus of power on time on it. There's no way to tell for sure. I don't think there's any type of hour counter or anything on these. Looking at most of the chips on here, the date codes are all 92. So 92, 92, 92, 92, so definitely at least 92 was the date this thing's made, which puts it, you know, well over 20 years old at this point. So I'll address the caps in a little bit here. I want to continue looking at some of the digital logics. It's kind of interesting, the things that are going on inside here. We'll start kind of in the audio path as far as things are going. So these 4 jacks back here are the actual analog inputs and outputs. And you can see a lot of the analog section here going directly to the digital section. So here's our ADC. That's a TI ADC 0809. I don't know the specs of that unit. I'll have to look it up. From there it makes sense because we've got our DSP right here, a VLSI chip, which is actually interesting because it's labeled as a Lexi chip. So this must have been custom made for Lexicon in terms of the DSP for these units, which is kind of neat. Finding the datasheet, and that's probably next to impossible to see what any specs are or anything like that. Got a 16 megahertz little crystal sitting next to it. Next to it here, there's obvious RAM, probably either DRAM or SRAM. Any C units, D4146C-10s. So I don't know the exact specs of those. 10 megahertz, possibly. Usually the dash digit there indicates the actual clock speed of it. From there, there's some other Motorola chips here, which then goes to a nice Burr Brown PCM 54HP, I believe it is. I have to look closer at that. So definitely spend the money on the converters there. Burr Browns are, or at least they were, some of the best back in the day, especially early 90s. All your high-end CD players would always have Burr Brown converters. I don't know what the actual sampling rate or the number of bits these converters are. I would assume 16-bit. It could be anything, though. I'll have to look that up. Being a professional piece of gear, I wouldn't be surprised if it was even higher than that. Maybe not, though, based on the age. So we'll have to look it up and see. On the opposite side of that Burr Brown chip, again, we've got a lot of analog filtering here, some small op amps. So that's probably the output, analog output filtering here, which then goes out to the audio output jack. On the front here, we got a Z80 microprocessor. Love it. Next to that, we've got our EEPROM. So there's our version 1.31 as far as the firmware that's on this. This is the EEPROM that you can actually upgrade to the 2.0 version. There's sellers on eBay just selling EEPROMs that actually have the 2.0 for like 25 bucks, which is annoying. I mean, I've got a million of these EEPROMs sitting around. If I could just find the actual code for it and write my own, but I doubt probably not going to spend the time even looking for it at that point. All those people are doing anyways, just pulling their own ROM, burning their EEPROMs and selling them on eBay for 25 bucks. We got possibly some programmable logic here next to that, maybe a PAL or a Gale or something similar. We've got some other chips in this area. I don't know the part numbers, they don't look familiar offhand. Probably some additional RAM for the microprocessor. Another Z80 back over here, which is kind of funny. So there's 2 Z80s in this unit, both 92, 22nd week 92 date codes. ST made as well. And then some more programmable logic back here, along with a handful of other 7400 series, just glue logic, tying everything together. This is definitely a classic 90s design, all through hole construction, which is nice from a troubleshooting standpoint, makes it easy. Almost everything's socketed too, which is also really nice. In terms of any part replacement or testing, it makes the troubleshooting a lot easier. So I wanted to take a closer look at the analog to digital converter in this Lexicon. Up at the top there's the ADC 0809. I pulled the datasheet for this chip and it didn't make sense to me because this chip specifically is an 8-bit analog digital converter with built-in multiplexer, and it's not designed for audio applications at all. So I realized that this wasn't actually the ADC for this unit, so that started making me wonder, what is the ADC? The position of it didn't make sense either. You can see on the board, looking at it, there's the analog side portion over here, digital side here, with a separate ground plane, following the analog digital supplies to indicate that. So it's pretty obvious this is all analog on this portion of the board here. There's these 2 Maxim chips that bridge both. I'm like, oh, those must be the analog digital converters, one for each stereo channel. Those chips are MX7628, which is equivalent to the Analog Devices 7628, which are also 8-bit digital to analog converters, so not what I was looking for. Those are actually used for certain leveling controls within the unit itself. So there's no other chips on the board that would be the ADC here, so I was confused. So I did some searching, and I was able to find schematic for this unit, so Ta-da! The entire thing, 8 pages of the schematic, which was nice because I was actually able to see what was going on. And I realized something kind of interesting in the design of it, in the fact that they weren't using a discrete analog to digital converter at all. They were actually using a delta sigma ADC in terms of a comparator. So what they were actually doing is the audio input is being fed into this comparator here, an LM311, and the actual output from the digital analog converter, the PCM54, is being fed into the other half the converter. And that's what's driving our actual PWM signal that's going to U25, which is the Lexi Chip-1, their DSP for this unit. So that's actually where their digital to, or analog to digital conversion is taking place at. Kind of a neat design. I wasn't expecting to see that in here. Lexicon specifies that the entire signal path through this device is 16-bit, so that makes sense. Now that I look back at the schematic and actually can tell what's going on. One thing you'll notice in the schematic is that they have these 74, 40, 53 tri-state line drivers here, here, and here. They're clocking everything as it's going through the analog signal path through the comparators, both on the input side and on the output side. One reason they're doing that is because this PCM54 Burr-Brown DAC, something I never knew about it is that it's a single channel digital to analog converter. They're actually alternating left and right channels in the conversion out of it, and then they're actually chopping it between left and right channels here through that tri-state line driver. Now, because the input's also chopped, they're doing the same thing here for the analog digital conversion through that comparator, which then that data is being clocked into the DSP. Something neat I never knew about that specific Burr-Brown DAC. It's like I mentioned earlier, it's used in a lot of CD players back in the 90s. It was one of the best chips at the time. I remember it was on a lot of spec sheets for higher end stuff, and even low to mid end stuff. But neat design nonetheless. So finally, after it passes through the little op amps here, it passes through a low pass filter, 15 kilohertz in this schematic, and then through a final op amp where it actually goes back to the analog board where it feeds through the analog outputs. So the last question was the ADC0809 on this board. What is it actually doing? It's doing a couple things. The analog levels from the input are being fed into there, and that's how the unit is being able to detect if it's getting an overdriven signal. The 5 pedal inputs on the back are analog pedals. Those are being fed into that chip as well, so that it converts it to digital, and you can use it to control various aspects of the device in terms of the algorithms and parameters of the actual algorithm. So for instance, with your reverb you can have variable delay and things like this. I wanted to take a little bit closer look at the power supply over here. You can see again where this cap has been leaking, the stained sticker there, and behind it you can see the corrosion on the board, and the traces a little bit in that area. So that one's definitely the culprit, but at this point I'll replace them all. No reason not to. Looking over here too, here is a backup battery, 3-volt lithium. I'll have to test that. It's already been replaced once. You can see the solder. You can see the solder there is fresh. If I can get a good angle in the light here. Lighting's not great on camera, but it has been replaced. So I will test that, see if it's good, which means one of these is at least a battery backed up ROM for the presets you would be setting on this unit for the various configurations and parameters for different effects, reverb, delays, etc. The power supply itself is really simple analog. So we got some, looks like National Semiconductor regulators in there, all LM series. You got a 5-volt, positive 15, negative 15. Nothing really special. Input side, you've got a couple caps there with the common mode choke, fused, 2 fuses, which is interesting because one isn't populated, but it's labeled. This side is the 240 volt side, and this is the 110 side that actually is populated over there. So it was like they put both connectors in there, and then based on the country or the voltage that was going to, it would actually be just adjusted that way. Which makes me move over here. You can actually see this jumpers right here for the transformer are actually the input settings, or the voltage settings I should say. So you can't really read the labels down in there, but they're labeled 110, 100, 120, then 240, 250. And just based on the placement of those, you can actually adjust the voltage for the country for that the unit will be used in, which is kind of a neat design. It's good to know for anyone looking to buy one of these units that's a different set for a different voltage, that you can easily convert it to the voltage of your country with really no modification at all. You just have to move some jumpers around and place a fuse in an appropriate fuse holder in the back here. And then the transformer is kind of a neat low profile design. You see these in a lot of 1U pieces of rack gear. Pretty beefy unit itself. I don't see any specs on it. I don't really feel like taking it out to see if there's anything on the bottom, but this old digital circuitry 5-volt stuff uses a lot of power, so I wouldn't be surprised if this whole board was pulling an amp or more. This stuff gets power hungry and it also gets hot. I'd be curious to know also how warm this thing runs after it's been plugged in for a while. But anyway, that's it for the inside for now. I'm going to power it up, hook it up to some gear so I can get some audio through it, and then take a listen to see if I can see how it sounds. Again, I'm going to replace these caps as well. I'm just not going to do it right now. I know the unit power is up based on the pictures online, what the seller was describing the unit in terms of functionality online. So we'll just power up first and then go from there. Alright, I got power hooked up. I threw the lid back on just for now. I got audio hooked up to it through my Roland JB80, and then the output of this is going through a mixer. And then I'm just feeding it directly to my computer right now so we can use the computer speakers just to hear the output. Give it a power up. Backlight works, which is always nice. LXP-15 1.31, copyright 91. So this must be a pretty early model of this, since all the chips were dated 92 and the copyright of it was 91, assuming that's when it came out. A little bit of noise there on power up too, but let's go ahead and... Well, that was interesting. Alright, let's... Looks like we got some scratchy pots, possibly. Ugh. Turn that off for a second. That's terrible. So, that was interesting. I'm curious if it's just the pots that are scratchy or if something else is going on here, because the pots are definitely a problem. Let me turn it back on. I'm going to turn the audio on my speakers down here really quick. That's just obnoxious. Turn it back on. Alright, those are definitely scratchy. Those need to be cleaned. They're passing audio directly through those pots. There's not any type of digital volume control in there based on just the sound of the audio there. And the input pot, the scratchiness too, is actually feeding through the unit, and you're getting the reverb out of it. Since I'm set to reverb right now. I know, actually put EQ reverb. That's strange. Alright, well, let me see if I actually get any audio through this. So it's passing audio. Let me turn that off. I need to clean those pots before I do anything else. So Deoxit D5 contact cleaner. I always start with this to actually clean the pots. And then the MCL, moving contact lubricant. This makes them feel really nice afterwards. So we'll go ahead and clean this. Clean both of these guys. There's little holes in the side here that, I have that on low, that I can get in there with and get the lubricant inside and cycle them. A little bit better angle. So, spray, cycle, cycle, cycle. Cycle, cycle, cycle. And this stuff kind of leaks and seeps out everywhere too, but that's okay, it evaporates pretty quick. Yeah, those were terrible, I couldn't believe. Hopefully it's not too loud on camera there. I was not expecting it to do that. And I can already feel these. Feeling a little bit smoother. I'm using the contact cleaner here. I'll spray this inside. Or the contact lubricant, I should say. I used to, part-time when I was in college, work for a recording studio that was nearby, and repaired their gear whenever they had issues, just for some additional money on the side. They had a beautiful AMEC Hendrix mixing console. I forget how many channels it was, 60 something. It was massive. The thing was probably 10 feet wide. Full analog, just beautiful, beautiful piece of gear. I don't remember how much they said it cost initially, but it was a small fortune. I was hired in because they were getting the unit again was on all the time. I mean, they had, I don't know, I don't remember if they shut it off at night or not, but it was on at least 8-10 hours a day every day for years and years and years and years. So two things happened. One, all the pots on it began to get scratchy and noisy. Each of these units probably had 15 pots in there for the various sends, returns, EQ, crossover points, gain controls, and the fader on the bottom. Every channel was just a module that slid directly out of it. And the caps on there too, they had probably 100 caps per board. So I pulled, basically they would pull 2 or 3 channels at a time out of it because they could obviously run the board without those channels. I took it home, lubed up all the, cleaned and lubed all the potentiometers, and then recapped every board. So I invested in a Weller desoldering station at the time, which worked great. I got to the point where I could do an entire board, probably, it was like 40 or 50 caps each, and cleaning all the potentiometers, each one in about 30-45 minutes. Just fly through there. Luckily all the caps on the board were only 3 values. I still have boxes of them, actually, for all those. I did all Panasonic 105 degree caps. Really high quality ones. It was kind of a fun project. Alright, I cycled those for a few more minutes. Powering up. Take a look to see if that has helped. It should have. Sometimes you need to work them a lot more still. Other times you just have to replace them. They're just so worn, and the carbon on the actual potentiometers is just deteriorated so much that there's no bringing them back. But output seems better. Input, it's better as well. Much better. Maybe it just needs a little bit more cleaning. Alright, so again, I haven't read the manual too much on this guy. Looks like reverb. I don't know. Let's pass some audio through it. And I did hear some reverb the first time I just played a little bit, so it's definitely reverb there, so it's working, which is good. Again, I gotta read the manual here to figure out how to actually adjust all the presets and everything. So I'm not too familiar with this unit yet, but pots are good, so I'm happy about that. And there is reverb, so it is working. It doesn't sound, in terms of audio quality, bad otherwise. Maybe these pots were the only problem. I've got to change those caps though. This place just stinks. It smells so bad. Well, okay, I'm happy with that. Let's look at the caps next and see if I have them. Spending just a quick few minutes looking at the manual. I realize you have to go into setup, then you can go presets and go through the default presets on this unit. So scrolling through some of the different halls and standard reverb presets in there. Definitely seems to be working pretty well. Default is 128 presets on this, plus you can custom create as many, I forget how many slots as you want, and that's what actually writes to that EEPROM with the battery backup for all your actual user presets in there. All the actual default presets are stored in the ROM, which is one of the ROMs there, probably sitting next to the EEPROM on the board. while I've got this powered up, I'm just going to go ahead and check voltages. So all the nice test points right here, outside the power supply. Not that it would be hard to follow, but it's just a safer point to probe. So you got your digital analog grounds. The plus 5 volts, obviously, our digital side for all of this logic in here, and 5 volts perfect, which is nice. Now the analog side, the plus and minus 15 volts are coming from these two caps here, one of which is definitely leaking, the other one which is leaking a little bit, so I'll be curious to see where they're at. So negative 15, a little low at negative 14.9, positive 15 at pretty much perfect on 15. So voltages are fine. Again, there's probably ripple on there. I could probe with my scope. I'm not going to bother because I'm just going to replace them anyway. And being the analog side, it would really only be impacting noise in theory on the output, because none of those voltages are touching anything on the digital side. Good caps. Rubbish caps. I always separated out my caps as far as the good ones I actually trust in putting in gear that I care about versus a lot of the cheap Chinese garbage I had acquired over the years that doesn't really matter. So we have 1000 microfarad at 35 volts and 2200 microfarad at 25 volts. I don't know if I have either of those. Maybe I'll surprise myself. 1000 at 16. I'm going to have to order them. I don't have any. 2200 at 16. I think I already saw those. Just for the heck of it, I figured I might as well check that lithium battery and just verify that it is indeed good. And 3 volts. It is good, so happy about that. It probably wasn't replaced too long ago. Those things usually last quite some time. In reality, 20 years I've seen them last or longer. So I got to order some caps. That's the bottom line on that. Clean up the board. This board doesn't look too hard to get out. There's a nut for one of the connectors in the back and a handful of screws, so it shouldn't be too bad. It'll just lift out, which is nice. Clean up all the acid remnants. Replace the caps. I'll do all 4 big ones in power supply. I'll just do all these in the power supply. The low voltage ones in the audio sections I'm not too concerned about. Generally, unless they look like they're leaking, they're usually fine. They're all high quality Lexicon units. The ones over here are only 85C rated, but again, I don't think this half of the device gets that hot, so it's probably not a problem. But nothing too exciting about the cap replacement anyway, so I'll just do that. But overall, I'm pretty happy with it. I think the only problem with this unit, realistically, was the noisy pots, which was causing the problems, which is why it was sold for so cheap. Again, the caps are maybe contributing to some noise. I haven't checked the power supply for ripple or anything like that, but I'm just going to go ahead and replace them. I know they need it anyway. So that is the inside of an LXP-15, and a pretty unremarkable repair, but repair nonetheless. I've got a working unit, so I'm pretty happy. Alright, thanks for watching.